Hey, welcome to part 2 of ESP8266 Web Server video. My name is Thomas and this is day 23 of 100 Days of Code in IoT Challenge. Yesterday I showed you how to turn your ESP8266 into a web server working on your local network and how to serve static files. Today the plan is to do a little bit more advanced stuff from ESP8266 perspective, because from the web server perspective it's not very advanced. It's like still basics of working with HTTP. But on ESP8266 it can be a little bit more tricky because we have limited memory environment. But yeah, enough talking. Let's move back to the code and continue working on the project. Okay, few more examples where one is gonna be about the headers. So headers, we can read the headers with this web server from the request, as well as we can send the headers in the response, right? That could be useful with the cookies, for example. If you have cookies, you want to have some sort of session, and you want to handle that session on ESP8266, you probably need a cookie header. You need to be able to send this header, like respond with that header, or read that header from the request, right? Working with headers with ESP8266 Web Server is a bit tricky because you have to specify all the headers except for the authorization. I'm not sure for what reason, but authorization is built in, is always going to be read by web server. But all the other headers you want to read, you need to specify beforehand, before you even start the server. So that needs to happen here. Before you do server begin, you need to call a collect headers method. Let me show you how does this look like. So that's server.collect headers, and that accepts header keys and an array of char strings and the size of that array, right? So I'm gonna have to create them beforehand. So yeah, let's just do const char header keys. And this is where you specify all the headers that you expect to get. So that needs to be, unfortunately, it has to be done beforehand, right? So there's no way really, at least there's no way I know with this web server class, to actually read the headers, on fly, right? So let's say there are some headers you don't know about, but you would like to read them inside the handler, inside the request handler, right? I don't know about any way with this class. If anyone knows, let me know again. I would really appreciate that, and maybe make another video about this. But yeah, let's just continue with what we have. Okay, so I'm gonna specify a cookie header here, maybe xtest. And what could be nice is maybe the content type, because even the default ones, they not being read by the ESP unless you specify them in the header keys. Okay, so that's for the header keys. We also need the size t of that array, and that can be done with the size of. But that needs to be divided by the size of char pointer, right? So that's gonna be 3, and yeah, we just passed the header keys. Sorry, that should be length or size. Maybe size is better. Size. So we got that, and we got size, header key size. Okay. So that specifies what headers we will be able to read. And also authorization header, for some reason you don't need to specify here. Okay, and now I'm just gonna work with the default endpoint, with a slash endpoint. And on the slash endpoint, what I'm gonna do, maybe what we could do is, yeah, let's read the header. So to read the header, that's just server header and the name of the header. So let's just do, maybe let's do all of them. So we've got cookie x-test content type, right? So let's do cookie, and the type of this is string. So my suggestion is, what I usually do, I specify some char, let's call it cookie, and that char I allocate some memory, and I use two char array method, and I just pass this buffer, right? This is this variable with the memory allocated, and yeah, you are supposed to pass the size of that buffer. So that's what I usually do. So that's gonna write the value of the header to cookie. You can work with the Arduino strings. So what you could do is just, you know, assign it to another string, or you can convert it to C string as well. But yeah, essentially this is up to developer how to handle that. This is gonna be one I'm gonna do with the cookie, you know, just as an example. Another one, let me just print it out. So that's gonna be what we have, x-test. So x-test, and what we could do, that's another way, right? So it's a server header x-test C string, right? So that's gonna convert it to const char pointer. And you know what? I'm gonna do the same thing with the content length. Content length. Okay, and that's gonna be also content length. So we will get this printed out in the serial monitor. And this one is gonna be assigned to the cookie variable. And here what we could do is to define something like a response body. So like more like working in the C way. Response body that's gonna have like 80 maybe, and we just use a print f on that response body, and we have something like cookie header, and then the cookie itself, right? The cookie itself, cookie header, it's 18. So yeah, maybe I give it a little bit more memory, and then this is gonna be something I'm gonna respond with. Okay, right. Okay, so yeah, let's maybe what else I could do is to change that to post. So we'll try with postman this time, and yeah, let's deploy the code and see how this works. Okay, deployed and connected, and let's open Postman. So I've got this already here, already prepared for that. However, the endpoint is just /, and what we want to do is we don't care about the body at this point. That's gonna be the next example, but we will have something like what do we have? We have content type, right? Content type, that should be content type. Oh, that should be content type, not content length. So let's change this to content type. So content type, x-test, and cookie. It's gonna open Postman, and that's what you're gonna have. So we have content type, x-test, and cookie. Some cookie value. That string is gonna look differently if you handle the cookies, but this is just for the sake of the example. And that's what we got. Cookie header, some cookie value. And we got x-test, and content length for some reason didn't work. Oh, it didn't work because I have to deploy it again. after the change to content type, right? Sorry, my mistake, I did content length instead of type. So quick deployment, and I show you again. Okay, deployed. I'm gonna send this request, and that's what we got, right? So you got x-test, content type, and that responded with cookie header, some cookie value. So that's how you read headers. If you want to write headers, there is a separate method to do that. Server send header, right? And you need to specify the header name. So let's send something like maybe x user, and the value is gonna be 1, 2, 3. So that's how the headers are sent on the response. I'm gonna deploy it, and we test it with the postman. Okay, that's deployed, and let's test it with the postman, and let's see what the response headers that we got. So we've got content type text plain, and x user is 1, 2, 3. Content length 30. So that's how you set headers. So that is for the headers, how to receive them, send them back, and so on. Another thing that we could do with this server is to read the body, the request body. Because sending the response body, this is pretty straightforward, right? I already showed you. It's essentially this string that you need to put on as a parameter on the send method. However, as for the request body, it is a bit more tricky. With ESP8266 Web Server, you can easily parse these two types of request body. Let me show you. Form data and x-www-form-urlencoded. These two, easily done. Let me demonstrate it. So I've actually got something prepared, a key on the form data with the value, with the key called value, and the value 7. Maybe I change that value to something else. Let's call it count, maybe. And the value of it is 7. To read this, regardless whether it's a form data type or x-www-form-urlencoded, what you need to use is method called arg. Arg that takes as an argument, it takes the name of the field you want to read. So in our case, we've got count. So that's what we want to do. We do count, and that returns string. So again, there's something that can be done with it. Let me just maybe again print this out just for the sake of demonstration, right? So as a C string, and I'm gonna count body param and s, right? Pretty straightforward. The way you can handle it again is exactly the same like can be done with the headers. So for example, like I've done with the cookie. If you want to do it in the C way, if you want to keep if you want to keep the string type, you can pass around the string. But yeah, for the sake of demonstration, I'm just gonna do it with I'm just gonna print it out and convert it to C string. So let me deploy it. Okay, done. And I'm going to call it again. And we should see something here. So what we've got is count body param is 7. And as you can see, the content type now is multi-part form data boundary something, right? So that's how you read that. If I change the type of the body, to x-www-form-urlencoded and call it again. Again, as you can see, this is where it starts. This is the previous one, right? As you can see, we have a different content type. The count body param now is null, and the reason is the name of the param. So let me do it again. Yeah, now it's 6, right? So that still works. The content type is different though. Cool. So that's how the body can be read on those two types. What about other types? What if you use raw text or JSON, right? The JSON is a very popular one with POST now, with REST APIs and everything. It is also possible to read JSON. I'm not gonna show you today how to parse JSON. However, I can show you how to read it as a text. So let me show you how to print out the body. To print out the body, right, that's what I'm gonna do. And what is needed to be done is simply server arc. Don't ask me why it's like that. Plain. Arc plain. So arc plain is apparently reserved for the body. So if you do server arc plain and you convert it to C-string, but again, it doesn't have to be converted to C-string. We can specify something like a char body first, right, and have like a limited memory allocated to it, and then use the just the server arc plain to char array body and size of body -1, and here we can just pass this body, but this time, yeah, the length will be limited, right? But yeah, any of those two ways, that's how you read entire body. And let me deploy, and I'm gonna show you how to actually, how does this work. It should basically display the entire body that we pass in the postman. I'm gonna prepare a request body, the text one first. So let's just call it text request body. Okay, this has been deployed and the server has started. And let's see what we get when I do that. Right, text request body. Great. There's nothing else really to be done to display JSON apart from changing the option here in the postman. So test 1, 2, 3. A is true. So some example JSON, right? I'm gonna send it. And this is what we got, right? For the code here, for the C++, this is still a string. There is another class that needs to be used to parse this and convert it to some sort of a struct of JSON. But again, this is gonna be another video. Right. Okay, I'm just looking at the list of all the examples I wanted to show you today, and I think that was the last one. Yeah, so we've got a stream file. We had a stream file, self-static. We had headers, collecting headers, reading arguments from form data, x-www-form-urlencoded, and reading entire body. So this is all covered now. You know what? Let me give you a step-by-step walk through the code again. Just, you know, to quickly remind how the whole thing works. Right, so here we just initialize the classes. Here we initialize the serial monitor. And we specify the endpoint. This is just specified, it's just, you know, it passes a callback function that is going to be called whenever that endpoint, which is the /endpoint, is hit. We try to connect to Wi-Fi. If it manages to connect, we print out the IP address in the local network of ESP8266, so we can use that IP address to call our server. MDNS is initialized. We specify the headers that we want to read from the request. They have to be specified with ESP8266 Web Server. They have to be specified beforehand, except for the authorization header for some reason. But all the other headers you are going to read, to not get empty values, you need to specify them. You need to create the array of the names of those headers and pass it to the collect headers method before you start the server, right? So that's what happens here. We're just telling the server, hey, these are gonna be the headers that we're gonna read at some point in the request handlers. We start the server and we set these two methods to be called on loop continuously with the timer tick, right? So they're gonna be just continuously called. That's to handle a incoming connection, right? And now, if someone hits that endpoint from the local network, that endpoint, right? What happens here? It verifies the method, the HTTP method. If it's not post, then it's gonna respond with an error. Let me try to do it. Not found, right? That's what we got, not found. Then what happens here? It reads the count body param that is on the request as either form data or x-www-form-urlencoded. Then it reads the cookie header and assign it to the cookie variable. It prints out the value of the X test header. It prints out the value of the content type header. Then creates a body variable and copy entire body to the body variable. Print this out, right, with the body and colon before, right? Then we prepare response body. What we do with the response body, we just assign a string, cookie header, colon, and the value of the cookie header. We send the X-user header on the response, right? And then we send the actual response body with the status 200 and content type text plain. Okay, so yeah, this is it from the basic functionality of the ESP8266 web server. I've just realized there was another thing I wanted to show you how to do, which I can quickly do right now. There is a server on not found. So there is a special handler for handling the not found case. So yeah, you can essentially overload the default not found request handler and respond on not found with whatever you want, right? So this is for the cases where you want to have a nice not found page. What I could do is just to show you what we could do with that. So this is not found, and I'm gonna quickly deploy it, and I'm gonna show you that this is gonna be the message on not found now. Okay, deployed and connected. And let me just call anything here. Yeah, so this is not found. This is not found, right? So default functionality is replaced with this request handler. Okay, that was a quick one, right? Okay, yeah, so that's it for the, as I said, this is it for the basic functionality of this web server. In the future, I'm gonna show you how to use a different type of web server. It's called async web server. It works a little bit different, but it's faster because it's asynchronous. But yeah, there's gonna be some video in the future, because tomorrow my plan is to present how the certificate store works. So we're gonna switch to HTTPS client again, but this time, instead of specifying a single certificate for a single host, I'm gonna show you how to make ESP8266 behaving like it was a browser on the SSL communication. So you're gonna upload entire certificate store, the one that is, for example, used with the Mozilla Firefox, and then I'm gonna show you how to verify the certificate per domain based on the information in the certificate store. And this is it for today. Thanks for watching. If you like my content and you want to stay up to date with my channel, I suggest hitting the subscribe button so you'll get notified as soon as I upload the next video tomorrow. Bye!